Welcome to a new e-learning paradigm, a plusmap.ai.
Hey everybody, today we're going to tackle comparative advantage. I know, it's one of those core econ concepts that can seem a little intimidating, but I promise you, by the end of this, you'll get it. And not only that, I'm going to show you a wild shortcut that lets you solve these problems in like 10 seconds. Seriously. So, here's the game plan. We'll start with a quick intro, then we'll walk through the two main ways you'll see these problems, the output method and the input method. After that, we get to the main event, a total game-changing shortcut. And then we'll wrap up by looking at why any of this actually matters out there in the real world. All right, so at its heart, comparative advantage is really all about cracking the code of specialization. It helps us answer one of the most basic and most important questions in all of economics. And that question is simply this: who should produce what and why? I mean, think about it. If you have two countries, or hey, even two people, and they can both make the same things, how do you figure out who should make what so that you're being as efficient as possible? Getting this right is the key to unlocking way more wealth and prosperity for everyone involved. Okay, let's dive right in with the first, and honestly, the most common type of problem you're going to see. We call this the output problem. And it's called that because the numbers we're looking at represent the final amount of goods produced. The total out. So let's meet our producers for today. We've got two countries, Alpha and Beta, and they both make two things: wheat and sugar. Now, this table tells us what they can make in a certain amount of time. So Alpha could make a maximum of 100 tons of wheat, or they could make 200 tons of sugar. Meanwhile, Beta can make 80 tons of wheat, or 120 tons of sugar. To figure this out, we're just going to follow a simple three-step process. Step 1, we've already done. We know this is an output problem. Step 2 is the real heart of it all. We have to find the opportunity cost. Once we've done that, step 3 is a piece of cake. We just compare the costs and find the advantage. So what on earth is opportunity cost? Well, it's just a fancy way of saying, what do you have to give up to get something else? See, the key isn't about who's the absolute fastest or who can make the most stuff overall. It's about the trade-off. For every ton of wheat Alpha decides to make, how much sugar are they not making? That's the real cost we're interested in. So let's calculate it for wheat. For Alpha, to get 100 wheat, they have to give up 200 sugar. So you just put what you give up over what you get. 200 divided by 100. That means the opportunity cost for 1 ton of wheat is 2 tons of sugar. Now for Beta, they give up 120 sugar for 80 wheat. 120 divided by 80 is 1.5. So for every ton of wheat Beta makes, it only costs them 1.5 tons of sugar. Hey, that's a lower cost. Okay, now let's flip it around and do the same thing for sugar. For Alpha, we take the 100 wheat they give up and divide it by the 200 sugar they get. That means 1 ton of sugar costs them half a ton of wheat. For Beta, we divide 80 wheat by 120 sugar, and that comes out to about 0.67 tons of wheat. So this time, Alpha actually has the lower opportunity cost, and this chart just makes it super clear. This is the cost for producing wheat. You can see it, plain as day. Beta's cost, that bar on the right, is lower than Alpha's. And the rule here is just so simple. Whoever has the lower opportunity cost, the shorter bar, has the comparative advantage. And all that math leads us to our final answer. Beta has the comparative advantage in wheat because, well, it gives up less sugar to make it. And Alpha has the comparative advantage in sugar because it gives up less wheat to make it. Simple as that. But what if the problem looks a little different? Sometimes instead of being told the total output, you're told how many resources it takes. And that brings us to method 2, the input problem. This is all about the time or the labor or whatever input it takes to make one thing. Take a look at this new table. We still have Alpha and Beta, and they still make wheat and sugar. But look at these numbers. This table shows the number of hours it takes each country to make one single unit of each good. This is a crucial difference. These are resources used, not goods made. And this means we have to completely shift our thinking. With output problems, bigger numbers are better, right? You want the highest production. But with input problems, smaller is better. You want to use the lowest amount of time, the lowest amount of resources. So how do we solve this one? Well, there's a really cool pro tip for input problems that makes it pretty easy. Once you know it's an input problem, you can find the opportunity cost by dividing the numbers kind of diagonally across the table. I'll show you. Okay, look, to find alpha's opportunity cost of making wheat, we take the input for the other good, sugar, which is 4 hours, and divide it by the input for wheat, which is 2 hours. That gives us a cost of 2 sugar. For beta, it's 3 hours for sugar divided by 3 hours for wheat, which is 1 sugar. Beta has the lower cost, so they are the winner for wheat. Then we do the reverse for sugar, and alpha comes out on top with a cost of only half a wheat. They're the winner there. And would you look at that? Even with totally different numbers and a different method, we get the exact same conclusion. Beta should focus on wheat, and alpha should focus on sugar. This just goes to show you how solid this economic principle really is. Okay, you've put in the work. You get the logic behind opportunity cost. So now, it's time for the reward. I'm going to show you the fastest, easiest way to solve these problems. This is perfect for when you're taking a test and you're on the clock. Here they are again, both of our tables side by side, the output table and the input table. Now, believe it or not, there is one simple trick that solves both of these in like 10 seconds flat. It's called the diagonal product method. And here it is. This is the big aha moment. For both types of problems, all you do is multiply the numbers diagonally. So in the output table, we multiply alpha's wheat, 100, by beta's sugar, 120, and we get 12,000. Then we multiply beta's wheat, 80, by alpha's sugar, 200, and we get 16,000. That's it. That's all the math you have to do. And I'm not kidding. Boom. You're done in 10 seconds. No more trying to remember which fraction goes where or which number goes on top. Just multiply and compare. But what do those two numbers actually tell us? Okay, this table is the key. For an output problem, the larger of the two numbers wins. So in our example, 16,000 was the bigger number. Now, which two things did we multiply to get 16,000? It was alpha's sugar and beta's wheat. And that's your answer. Alpha gets the advantage in sugar, beta gets the advantage in wheat. And for an input problem, it's just the opposite. The smaller number wins. You just find the smaller product, see which two goods made it, and you've got your answer. It's that easy. So we've crunched the numbers, we've learned the shortcuts, but let's just pull back for a second and look at the big picture. Why does any of this matter? Because this isn't just some abstract exercise for a class. This is literally the foundation of modern global trade. This right here is the magic of comparative advantage. It shows that when countries specialize in whatever they make at a lower opportunity cost, and then they trade with each other, the entire pie gets bigger. The total amount of stuff in the world increases. Both countries can end up with more than they could have possibly made on their own. It's not about being the best at everything. That's a different thing called absolute advantage. This is about being relatively more efficient. And in this system, everyone can win. So now you know the secret. You've cracked the code of comparative advantage. And it kind of makes you wonder, doesn't it? What other big, complex ideas in economics are actually way simpler than they seem? Think about that one. Thanks for tuning into this explainer.
We hope you're excited for what's next. For more learning materials, please visit aplusmap.ai.